Well, congratulations. This is the last couple problems of the Chapter 9 test review. Remember, you can always go back, rewind, rewatch, ask questions. Make sure that you don't just write in the answers, that you understand how to do these problems, because you're going to be given similar problems, but they will be different for your test. So be ready to solve any problems like these using the structure that I provided in how to solve these types of problems. All right, the graph shows the number of words Mason read in a given amount of minutes. If Mason continues to read at the same rate, how many words will he have read in 5 minutes? Well, here they've started to show us this graph. And notice from each point they're going up 2 over 1, up 2 over 1, up 2 over 1. So if I go up 2 over 1, this should be my next point in the graph. And that is right at 5 minutes. So if he reads for 5 minutes, that would be 1,000 words. So once you notice these patterns, you see these patterns, that's why graphing these equations can be effective, because now you're able to figure out, well, okay, what about 5, 6 minutes, 8 minutes, without doing the math, because you do the math on the first few and then notice that it has a linear relationship, meaning it's going to create a straight line, graph that line, and now you can see all the other points. So once I found this pattern, I can see that my next point's going to be here, and that's 5 minutes, which would mean 1,000 words. Okay, number 17, last problem. Casey claims the linear equation for the relationship shown by the graph is, she says this is the equation. Use numbers and words to support Casey's claim. We've been talking about claims and writing. So let's see. First, I'm going to go ahead and graph this line that not perfect. So let's see. My equation is going to be C, the cost. Here's my cost, is 25 times the number of jumps. So if we plug in 1 for J, 1 times 25 is 25, that's true. If I plug in 3 for J, 3 times 25 is 75, that's true. If I plug in 5 for J, 5 times 25 is 125, that's true. Okay, so it looks like Casey's claim is correct, but let's try to prove it. So for example, if it's 2, we should get 50. Now that looks like it's where it ends up on the line. If we use 4, we should get 100. That looks where it ends up on the line. If we use 6, we should get 150. All of these are working. So what you want to write here is something like, yes, I agree with Casey's claim, because any number I use for J, when I plug it in, I get the correct C value. Okay, so that's what you're going to write here, and you could put in some of those ordered pairs. These are all ordered pairs that lie on the line, you could also say. Okay. All right, thanks for watching, and I will see you on the next one.